so you need help with problem number 3. Problem number 3 is a balancing the equation problem. If you're actually looking for number 4, that's the next video. But if you need some help balancing this equation or you just want to check your answer, I'll work it out right here. You can always jump to the end of the video to see if you got the answer right. So, this is a review. Things you guys mastered back in February, I think. So we have carbon, hydrogen, and oxygen. I like to list them out below to help keep track. On the left-hand side of this arrow, on the left board, we've got 2 carbons, we've got 2 hydrogens, and 2 oxygens. On the right-hand side, we've got 1 carbon, 2 hydrogens, and then oxygens are tricky. This is where I like to write little numbers up here to keep track of it. We've got oxygen, carbon dioxide, and oxygen and water. So we've got 2 right here, and 1 right here for a total of 3. Now, I'm going to go ahead and start going down this list, see what's not balanced. We see the carbons aren't balanced. We see that this side, the right-hand side, needs more carbon. So if I put a 2 right here, a coefficient of 2 on carbon dioxide, that means we now have 2 carbons. But that 2 also applies to the oxygens in carbon dioxide. So that means we have 2 times 2 is 4 oxygens, plus that 1 oxygen over here from water, for a total of 5 oxygens. All right. Some of you might be seeing where we jump ahead. I'm going to work this out a full long way. You should recognize, though, that we have an odd number of oxygens here. We need an even number, so that should tell you that you need to double something to get it to be an even number, but we'll work it out. So carbons are balanced, hydrogens are balanced, 2 oxygens on this side, 5 oxygens on this side. That means the left-hand side needs more oxygens. So let's see. If we try to put a 2 right there, over here with oxygen, 2 times 2 is 4. 4 is not enough. Let's up that even higher. Let's try 3. 3 times 2 is 6. Well, that's still not the right answer, but that side doesn't need any more oxygens now. Now this side has too many and this doesn't have enough. So we need to up the number of oxygens on this side. And let's try to be strategic about this, because we have 2 options. We could increase the number of oxygens from CO2 or from H2O. Now, part of our issue is that we have this O2 over there. No matter what coefficient we put here, we are going to get an even number of oxygens. So it'll either be 2, 4, 6, 8. There's no way we're going to get the 3, 5, 7, or 9. No whole number we can put there. So we need to get this to be an even number if this is ever going to work out. Now, no matter what, we also see that we have a similar problem over here. CO2, no matter what coefficient I put here, I'm always going to get an even number because of this 2 down here. I could put a 3 here, that would be 6 oxygens. Before there would be 8. No matter what I do, we're getting an even number of oxygens right here from carbon dioxide. But from water, there is no 2 there. So I could put like a 3 here. And if we put a 3 there, 3 times 1 is 3, 4 plus 3 is 7. That's an odd number. Let me put that back. We don't want to do that right now quite yet, but we could. No matter, we could get this to be an odd number. So we need to make sure it's an even number, though, because we can only have an even number on that side. So let's only be putting 2, 4s, 6s, 8s, and 10s, and so on here, okay? Otherwise, it's going to give us an odd number as our answer, and that's not going to work. So we need 1 more oxygen. This has 1 oxygen. Actually, if I were to put a 2 here, that means we now have 2 oxygens here. We just upped it by 1. And we know that 4 plus 2 is 6. So the oxygens are now balanced. Now the issue, though, is that we've unbalanced the hydrogens. 2 times 2 is now 4. All right. Well, we got a little more work to do. So these are now balanced, carbon and oxygen, but we've unbalanced the hydrogens. So again, we're going to ask ourselves the same questions. Which side needs more hydrogens? We see the left side needs more hydrogens. Well, we find hydrogen over here and ethine over there, C2H2. Well, how can we get us 4 hydrogens? Let's try putting a 2 there and see what happens. If we put a 2 there, 2 times 2 gives us 4 hydrogens. So the hydrogens are now balanced, but you're going to notice that that 2 is also going to apply to that carbon in ethine. And so that's going to make it 2 times 2 carbons is 4 carbons. It feels like it's never going to work out, but I promise you it will, okay? We just keep asking ourselves some same questions because we see that we've now unbalanced the carbons by balancing the hydrogens. So we're back at the top again. So, which side needs more carbon? The right-hand side needs more carbon. Where's carbon on the right-hand side? Well, it's in carbon dioxide. Right now we have 2 there. We want 4 carbons. So let's go ahead and try putting a 4 here and see what happens. We put a 4 there. 4 times 1 is 4 carbons. And we keep going this way. That's balanced finally again. Okay, that's good. 4 times 2, though, gives us 8 oxygens. And then the 8 plus the 2 over here from water is a total of 10. So guess what? While we've balanced the carbons, we've balanced the hydrogens, you know what's unbalanced again? Those oxygens. But this is looking better this time because we see that this is an even number. And we won't have that odd number problem we had earlier that kind of messed everything up. So, because this is an even number, let's see, we need 10 oxygens. What coefficient can we put on O2 over here that will give us 10? Well, what times 2 is 10? We all know that that is 5 times 2 is 10. So we can put a 5 there. 5 times 2 does give us 10. And so we see carbon has 4 on each side, hydrogen has 4 on each side, and oxygen has 10 on each side. And this is the balanced chemical equation. You have a 2 here, a 5 with oxygen, a 4 with carbon dioxide, and a 2 with water. So that should have been your answer for number 3.